Alright guys, so today we're going to be doing the first major test of my battery, solar, and generator system. Everything is in. It's not completely clean, as you can see back here, but until I get this test and everything done, I don't want to do too much with tidying up all the cabling and stuff in case some things need to change. I have two Victron Multiplus UL listed 24 3000s. So these are in split phase 240 configuration, and they are running off a 360 amp hour 24 volt self-built battery with CALB cells, at an Orion BMS Junior. And then everything is controlled or monitored by a Serbo GX. We've got 4-aught battery cables going in to make sure that we can handle everything with 500 amp, well, 400 amp fusing Class T, 500 amp contactors, 500 amp disconnects. And then we have a Victron solar MPPT that is a 4870, 15070 TR, and it's running 24 volts with only about 1,000 watts of vertical panels in the back that we can see another time. The big thing for today is going to be testing the AC configuration with the power assist. So I have a transformer right here, an auto transformer, and the auto transformer usually is set up to balance loads between the two inverters to make sure that one inverter doesn't overload if you've got just a 120 load on it. This one, however, is set up to do 120 volt single phase to 240 split phase conversion. So what we're going to be doing here is essentially trying to connect the entire house to the inverters, and we're going to put 2 of the 2400 watt max inverter champion generators that I've had in a few other videos. We're going to have those in parallel. They'll do continuous 1850 watts each, so about 3700 watts or around 32 amps, 120 out continuously. So we're going to run those into the auto transformer, convert it to 240, which will go into one phase essentially each into the inverters, and that's going to go straight through on a 50 amp connector. So I've got both of those coming down into a small AC load center with a couple of 20 amp breakers, a 30 amp breaker, and then a 50 amp 240 breaker. And the 50 amp 240 breaker is going out to a flying lead with a 50 amp twist lock connector on it for 240. This is the same kind essentially that you'd have on like the generator inlet of a house. So what we're going to do is go from the generators with around 3700 watts of power into the auto transformer. The auto transformer is going to go into the inverters, and the inverters are going to go to the panel and then out to my main electrical panel for the house. Theoretically, this will run things without problem in the house, refrigerators, things like that, zero issue. It should be more than enough power for a lot of that. The big one today is we're going to try and kick on the AC unit. I believe it's a 3.5 ton, maybe a 3 ton. I've done another video on that with putting the soft start on there. So the soft start should drastically help essentially make this possible if it works, because what we're going to be doing is momentarily these inverters are going to be using Victron's power assist, so that when the AC unit starts up, it will be momentarily drawing from the generators at 3,700 watts and then adding any additional that's needed in with the inverters to start the unit up. And then it should drop back down and go back to just running on the generators, or we can lower that down and run part of it off of the battery. These inverters right here are 3,000 VA each, which means they're somewhere around, I believe, 2,400 watts at like 70 C or something. Essentially, all day long, they will do about 20 amps 120 each. So 20 amps 240 between the two of them. And this can be added into the power from the generators, which is going to be about 15 amps 240. So we should get about 35 amps 240. These, however, can go up for a half a second to 6,000 watts each. So I should be able to do about 6 kW of 240 plus the generators. These can also do 130% of the 2,400 watts for about, I think, 45 minutes or so. So they can go well above their rated load, just not all day, every day, continuous. So we're going to make a few connections, and I'm going to put some monitoring on some things and turn the thermostat up so that we can kick it down to put the unit on later. And I will see you guys in a minute. Let's hope all this works. All right, we got everything connected. The generators are out back filled with gas and connected via their 30 amp output in parallel to the input over here on the transformer. And then the output is connected right here from the flying lead off of the 50 amp breaker into the cord that goes out to the generator inlet on the house. So now what we're going to do is we are going to turn on the 50 amp breaker and then switch over to the generator inlet on the main panel for the house. See what we can turn on and measure some stuff. I've got it screen recording on the Victron app, and see just first off the batteries without the generators running what it'll do, and then we will kick the generators on and see how all that works, and then we'll fire up the air conditioner and see if it can pull it in and run it. All right, so we just powered up everything but the 240 loads without the generators running. So right now we've got a little over 1,000 watts powering every outlet, everything in the house, refrigerators, internet, lighting, the gas water heater, electrical system, the igniters for the stove in the kitchen, fans, ceiling fans, just everything right now is running entirely off the battery, with the exception of the 240 loads, so the clothes dryer, the air conditioner, outside unit, and the air handler. We're going to give this a second and see how it does. Everything seems to be handling just fine. And then we're going to go out and start up the generators and see what that does. Then we'll get this air conditioner kicked on. Generators are on. As you can see, we are in pass-through where it says grid input. That is coming in from the generators. So we've got basically all of our loads right now are powered off the generators, with nothing going to, well, I say that there's actually a little bit going to the batteries. So right now we are drawing a little over 1,000 watts, and then it will actually start charging the batteries up for us when we're not using that much. So what we do is we set the input current limit, which is kind of the size of the generator or the max load you want to put on the generator. And then if you're using under that, it will basically charge the battery with that until the battery's full, in which case it's just going to power your loads and reduce the load on the generator. And then if you go above that limit, it will start pulling from the battery to assist in the generator. So it's never going to go over that current limit that you set for the input. So that's what we're going to be doing here shortly, is we're going to be adjusting that current limit to make sure everything's good and that it will use the generator to its full capacity. And then we will be adjusting everything and turning off. I want to turn off our other loads so it's just the air conditioner on, so we don't end up with kind of a false thing of something kicking on at the same time or whatever. I just want to see if we can run the air conditioner off of this battery and generators. Let's get to it. I've got it set for 80 so it won't kick. Everything should be on. Let's see what she does. All right, it looks like it is running entirely on. Looks like it is running entirely on the generators and the battery combined. Let's see. Let's see what the easy start says. Alright, status is normal. Last start peak was 34.8 amps. And that's currently using 9.7 amps at 240 volts. Alright, we are going to now up the current limit on the input, load the generators up a bit more, and see if we can get it to where it is not having to assist. It assisted on the startup. I want to get it to see if we can pull it just on the generators for the running once it starts. Alright, it looks like we have a slight issue. For some reason it will not load the generators up. I don't know. It keeps saying the current limit's too much, so I don't know if it's the auto transformer or if the generators can't handle it. But it is running off of the battery and inverters, just not the, or off of the generators and the battery, but just not the generators only. So let's see what's going on with that. So the generators are only running at about 11 to 12 amps each. Alright guys, I just kicked the air conditioner off, and as you should be able to see on the screen recording, it immediately started charging the battery back up, and it keeps a kind of consistent load on the generators. This may be more than you would want to run continuously on them. That's quite a big load for them to just sit there and run constantly. But the air conditioning is not something that you would always be running. So just every now and then for a little while to cool the house down, pull the humidity out, things like that, it would kick on and need the generators and the battery to do it. I think we can get it to just the generators if we can get this voltage drop sorted out, and we will have to see because then it wouldn't be lowering the battery at all except for other loads in the house and things, or from just the starting of the AC unit. So I'm going to keep playing around with this, and we got a lot more work to do. Future me here. So the test went really well. I just wanted to break down a few of the data points that I collected while doing the tests for the generators and the battery, and a few tests that I actually did afterward based on some of the data that I did get during the initial testing. So the air handler and the compressor unit for my heat pump. This is a 3.5 ton 14 SEER heat pump. Indoors, it is a standard air handler with electric heat strips and dual zone controls. So it's one air handler for the whole house with a valve essentially in the ducting that can open to divert air either to the upstairs or the downstairs with two separate thermostats. This means that we pretty much pull around the same amount of current regardless of the upstairs being cooled or heated or the downstairs being cooled or heated. So the information essentially that was gained from this is going to be pretty much the same as long as the heat strips don't get kicked on, regardless of whether I'm using air conditioning or I'm using heating, and whether or not I'm doing the whole house or if I'm doing just the downstairs or just the upstairs. The only difference is going to be how long the unit needs to run to cool off those areas, which means essentially if I wanted the unit to run less, so less energy over time, then I could kind of zone off just one section and only heat or cool that area. So 3.5 ton unit. This does have an easy start soft starter on it, and that is essentially what makes this possible. Without that, the locked rotor amps on this unit are like 70 plus amps at 240 volts. So not something you're just going to be able to pull in. I know it's not necessarily that way, but that is the nameplate locked rotor amps for this unit. So what we were seeing with the metering was around 34 to 35 amps at 240 volts to start the unit up. This is about between 8,000 and 9,000 watts, so say 8.5 kW, and then it would drop down to just the compressor using about 2,400 to 2,800 watts, or about 10 to 12 amps, 240, with the interior air handler unit bumping that up to about 3,300 watts, so 3.3 kW for the whole system once it was running. What this means is that although my generators, which are two inverter generators, they're 120 volts only, and in parallel they are capable of outputting 3,700 watts. What I found was that the 3,700 watts on those, that's the continuous running at 1850 per generator on gasoline. That is reduced a little bit with propane, because they are dual fuel units. But essentially, you would not want to run the units on just the generators. It ran it too high. It was loading the generators down too much, and any little surge, anything that happened, the unit working a little bit harder would want to trip the generators out. Additionally, you are losing a bit of voltage over the length of the cable runs, and so that's putting more strain on it and wanting to pull more current. So overall, while it is technically doable, it is not advised, and it's not something I would want to do. You generally would not want to run the generators up that high. I found the best usage case was using my battery system in combination with the generators, so that it was pulling around 1,000 to 1,200 watts out of the batteries, and then only putting about a 2,000 or so watt load on the generators. And what this enabled me to do is it would start up and pull the starting current essentially from the batteries. I found that the battery and inverters were more than capable of pulling in the unit and running it completely by themselves. No generators needed, so if needed, then I could in fact run just the air conditioner off of the batteries only with no outside power. This is good, but it would deplete fairly quickly. You'd only get around an hour and a half or so before you would need to recharge things. But what that means is that, let's say a worst case scenario, I've got a 1 hour on, 1 hour off of the air conditioner. So it runs for an hour, then turns off for an hour. This is not what it would normally do. It would normally probably run for 15, 20 minutes and then turn off for 30 minutes, 45 minutes to an hour, and then run again, depending on how low the temperature is that you're trying to reach and how hot the outside temperature was. So on this day, as you can see from the video, it is incredibly hot. I don't look like I'm doing well. It was 92 outside with probably about 70% relative humidity. So it was very hot, especially in the direct sun, UV index of like 8 to 10. So if you were running just on the generators, again, or just on the battery, it would not last that long. But if you are running this 1 hour on, 1 hour off, which would be about 44 kilowatt hours a day of usage, which would be higher than my normal electric bill, so clearly this is kind of a worst case scenario. What that would mean is that over an hour, you would pull around 1 kilowatt hour from the batteries. My batteries, again, are about 8.6 kilowatt hour capacity. Then it would drop down to where the load, when the AC was off, would be running only on the generators, and the excess power from the generators would be going back into the batteries over that hour. You would only need around 1,000 watt load on the generators plus whatever the house was drawing. So again, let's say 1,000 watts for the house, you'd be pulling another 2,000 watts or so, so about the same to a little over what you were with the air conditioning. This is a setting in all of the Victron system. So I am running a pretty much completely Victron system with the exception of the self-built battery. It is 2 Victron Multiplus 3000 inverters, a Victron auto transformer, Victron solar charge controller, Servo GX. So all of this is programmable with the units for the assist. What this means is essentially I can tell it when you have power coming in from the grid, from the generator, whatever, when you have power coming in, limit it to this amount. So in this case, I found the best to be somewhere around the 10 amp setting on the input limit restriction, which is 10 amps per phase. So that would be about 20 amps 120 or 10 amps 240. You can then limit also the charging on this. So what you would essentially do is limit the amount that it can ever pull from the generators. So if the air conditioning is running, it is going to assist anything over that 10 amps or so. And then once it drops back under, it will still keep pulling that 10 amps, but it's going to start putting that into the battery. So the load on the generator actually stays pretty consistent. You might want to vary this a little bit to not wear your generator artificially at a kind of a weird level and burn excess oil and things if you were doing this long term. Again, for me, this is just kind of for emergency use. So overall, my system works kind of how I want it to, and I think it would be good. After the fact, like after these tests, I shortened the generator inlet cord into the system from about 100 feet to 50 feet of 10 gauge cable. And again, this is 120, so 30 amp maximum, but over that length, I was getting too much voltage drop. I am also running into an auto transformer to change it from 120 volts to 240 split phase, and I was getting a little bit of voltage drop across that. The tap on those is also not always completely in the center, so I had one leg of the output that is lower. What this meant is when it was loaded, that one leg would overall drop below the input voltage threshold for the Multiplus units, and they would drop the input entirely and run solely off the battery. So if I tried to pull too much current across that cable, it essentially would say, we're seeing that the voltage is dropping too much, the load can't handle this, and so it would switch over to not pulling enough off of the generators. Decreasing that to a 50-foot cord helped significantly. It actually allowed me to get another probably 400 or 500 watts out of the generators, which meant that I was only pulling about 100 or 200 watts from the batteries total. I have no doubt with a shorter cord or a heavier gauge cord, I could probably make that to where it just ran off of the generators. But this is starting to run the generators up around their max capacity, which if you're running that, 15 to 24 hours a day, that's not something you're going to want to do. That's not going to be good for fuel economy. It's not going to be good for the life of the generators. So while it is theoretically possible, it is not something that you would actually want to use. So the reduced cable length on that did help. The rest of it is probably some combination of the auto transformer. The auto transformer is not my end goal with this system. The auto transformer is really for balancing phases on the output. Since I have two of the Multiplus units running essentially out of phase with each other, where one handles L1, one handles L2, 180 degrees out, I can pull 240 load across them and double my wattage. However, I cannot pull a 120 at double the wattage because they're not technically in parallel. So what this means is that if one of the units gets loaded beyond the 2400 watts or 3000 VA load for that unit continuously, it will trip both of them out, even though that's only on one leg. So the auto transformer is going to go on the output and convert the 240 to split phase 120 so that it can balance the load between them, so I'm equally drawing across both of them regardless. That essentially would allow me to pull pretty much the full capacity across either L1 or L2 in some combination. So in the future, my goal is going to be to get a still fairly small 240 watt or 240 volt output generator, an inverter generator with this system. Ideally, if you were just running a generator to run your house and you wanted an inverter, you would probably, with a system like this, want somewhere in the 9,000 watt range. And those are the big inverter generators. Those are the ones that cost in the thousands of dollars. So with this system, it will enable me to get a smaller generator that doesn't have the starting capacity, but has more than enough running capacity. So probably in the 6,000 watt range. And a 6,000 watt inverter generator is around to a little under probably $1,000. Whereas a 9,000 watt inverter generator is almost double that, depending. Also, there are a lot more of the smaller ones available. That does kind of limit when you start getting the 240 volt output. But basically, I will be able to go 240 volts into the Multipluses, L1 and L2, respectively, and then out to the auto transformer, and it will perfectly balance the loads. And even running just on the generator without the assist of it, it will only be running the unit at around half capacity. So the generator will be happier. It won't need to pull anything from the batteries except on startup. And so that overall is going to be a good upgrade for things. So why would you want to do this at all? And the answer is you probably wouldn't. For me, this is a learning experience. This is essentially the same kind of setup that you would use in something like a large RV or camper. Or if you've got like an off-grid property with a cabin somewhere, something like that. And I really wanted to learn how to do this, how to do the electrical systems, how to do things integrating with solar and generating my own power. And so for me, it is a big educational expense. For most people, this is not what you'd want to do. If you just want emergency power, just get a big generator. It's going to be far cheaper. Now, if you are off-grid, then it's kind of a no-brainer to have the battery system. It is going to give you the ability to turn the generator off at times and let it cool down, refuel it, change the oil and things, all without ever losing power. The battery will take over in that case and use that. You can also integrate solar in with it, so you can reduce the load on the generator or only run the generator if the solar is not keeping up. Wind, things like that, the battery is going to be a definite go-to if you've got a camper, RV, or an off-grid property. Time of use electric rates. If you are somewhere where energy is cheaper in the middle of the night and it's very expensive during the day and you use a lot of power during the day, it actually can be beneficial to run a battery that charges up overnight and then you use your battery during the day. Even if you are not necessarily using solar or something like that, you can actually get a pretty good payback over the years on just having a battery, depending on how expensive your electricity is at different times of day. If you have solar and you want it to work when the power is out, you have to have a battery. You have to have something for that solar to go into, or it's just going to shut off. And those are very specific systems. They have to be rated to do that. They have to have islanding capability where they can disconnect from the grid and be self-sufficient. The other thing is, if you want to use a generator with solar, again, you have to have somewhere for that power to go, so you have to have a battery. So if that's you, one of those systems is also going to be more beneficial. There are a lot of commercial systems that are available that are working in this way. Most of them that are working in the way that my system does are fairly new if they are not self-built systems. The all-in-one units and things, doing generator assist and stuff is a fairly new capability for a lot of them. And so you start to get a little in the weeds with the technical know-how and having a system designed by a professional to do this, unless you just really like tinkering and love some headaches. If you are wanting to reduce your generator size and your fuel usage, just like I explained earlier with my system, then you will also benefit from this. It is more expensive than a generator. That's a given. Batteries are really pricey. These inverters are not cheap, especially the UL listed ones. The wiring, all the complexity of it, and the know-how, like, this is a pricey system. It is not as expensive as something like a Powerwall or one of the pre-made things. It's still cheaper to do it yourself. However, it is far more expensive than just getting a generator and plugging it in. But if you are the kind of person that wants to use the battery in combination and use a smaller generator, this is kind of the only way to go. There are new systems that are coming out from both companies like Anchor and EcoFlow, and I'm really interested to see a lot of those. They're Delta Pro Ultra, and then I don't remember, I think it's like the Anchor Solex. Some of those are starting to do the same kind of thing where you can have a battery system and it can have an input kind of all-in-one, an input of solar in, be connected to like an emergency panel in your house, and have a generator input. I know the EcoFlow can also start their generator, at least if you've got their specific one. But a lot of these are working in combination with the generators and kind of doing the same thing all in a very pretty package. They are pricey. I mean, they're, I think you're talking like $5,000 buy-in kind of on the lowest level for the EcoFlow, and then they go up from there. For what you get, that could be well worth it, especially if you have looked at doing any kind of RV electrical system or anything like that. Once you get out of just being connected to the power poles and the utility and using your power at an inexpensive rate directly from them, anything outside of that starts to get really expensive really quickly. So when you look at these systems, don't compare them to plugging into a wall outlet. You've got to compare them to if that power wasn't there, and then everything starts to make a lot more sense. If the power's there, obviously, just use it. I have solar in combination with this. It is not roof mount solar. It is actually kind of an experimental setup that is completely vertical to take up pretty much no space in my yard. And so it is not producing at max capacity. It is around 1,000-watt array. It's a fairly small array of smaller panels, and it is only giving me around between 3 and 4 kilowatt hours a day of generation. This keeps the batteries topped up, takes away the idle draw of the inverters on my system, and then gives me a little bit to use for some lights, maybe the refrigerator, just to offset the usage on my main electric a little bit. My system is going to be essentially for backup, kind of like a UPS, where I don't have to have a generator start up. If I'm not running the air conditioning, that battery can run pretty much everything in my house for 8 to 12 hours at least. If I were to reduce my loads and stuff, at least a day, just entirely on battery. This is a big deal for me, being in hurricane area, with not having to put my portable generators out in the middle of a hurricane, which will damage them. If you've got a standby generator in a nice, pretty enclosure, that's not a problem for you. But also, I love the fact that it's the majority of power outages that people get are going to be in the span of just a couple hours or so. They're not usually long-term outages unless you have a major, like, catastrophic event, in which case something like a battery like mine is amazing, because basically I will have an automatic I've got an automatic computerized transfer switch that's going in for my critical loads, and that's going to be all of my lighting, internet, TVs, and then the electricity needs for my gas appliances. And those are all going to function as normal. And the transfer time on that is like 10 milliseconds, which means that you're not even going to notice that it goes out. So that's a big plus with this. It's not the power goes out, then you wait a little while, the generator fires up, runs, and then the power comes back on, the generator turns off. If you've got like a 15-minute power outage, the battery is an amazing thing, because you're not running your generator for like 10-15 minutes. It is literally just running the whole house off of the battery, and you're not even probably going to know, depending on what loads you've got on this panel, you're not even going to know the power went out at all. Your TV will stay on, your computers will stay on, your lights will stay on, they just transfer instantly. And that's kind of my go-to, is going to be, the battery will run the system for those short outages, and then if it's a long-term outage, I put my generators out. Again, in the future, hopefully a slightly larger one, but I put my generators out, and I can charge the batteries back up as needed in combination with whatever solar I have. And so I kind of have the best of both worlds. Again, not for everyone, but in the future, you're going to see this a lot more with these portable batteries, these home batteries, the very large portable batteries that are really meant for your home and RV and things like that, from Anchor and from EcoFlow. The stuff they're doing with it is amazing. I wanted to build myself again because I wanted to learn how to do it, and to not necessarily be stuck in with one ecosystem entirely. I built my battery. This has been a span of years. Most of this stuff did not even exist when I started building and designing my system. If I had to do it all over again, I would really, really strongly look at those pre-done systems, because they really are amazing. That would be the only thing, is that you're then kind of tied to their system. So going forward, my system is going to get cleaned up. Everything worked how I wanted it to. The flying lead for the generator power output into the plug on the outside of the house. That's all going to get tidied up and going to be an actual like NEMA 1450 outlet, so that I can just plug in and then plug into that generator inlet on the side of the house. Again, because that is a manual transfer. The auto transfer will be a smaller amount of loads, and that will always be connected to the batteries with its own breaker. And then and only, like, so if I'm away from home or anything else, it'll keep the refrigerators running, things like that on the battery. If I'm home and need to put the generators out, I will make the physical connection to the power inlet. That way, a lot of it is also staying more temporary and is very easy to move, to undo, things like that. I don't want to put a huge permanent system in right now. The cables, if I get a 240 volt output generator, that's going to completely take away that voltage draw essentially. Because even at 30 amps, if I've got 30 amps of 120, that's 15 amps at 240. So a 10 gauge 4-wire cable is essentially going to carry the same amount of power with half the current on it, which means essentially half the voltage drop. So for my lengths of cables and things, that will be a big saver. I won't have to run these huge cables in if I'm running them in on 240 split phase directly from the generator. This also means my auto transformer is going to go on the output, again, to balance my loads and things. So those are some minor changes that I want to make to the system. Covers and buttoning everything up, making it look nice and professional and pretty. But again, I didn't want to do that, as I said it kind of at the start, I didn't want to do that until I knew everything was working exactly how I wanted it, to make sure that I didn't need major design changes or to start over with something. This brings me to the kind of the overall outcome of why I did a lot of these tests. If you are going to be running something in an emergency, anything like that, if you've got a generator, do not just buy a generator and plan to stick it outside and put it in your garage with a few gas cans and say, oh, when the time comes, I will use this and it'll be great. No, the time to plan is not in the middle of an emergency or a storm or this major power outage, heat wave, ice storm, whatever. The time to figure out what you need to do is when you've got a free weekend and can shut the house off and test it yourself, because you may find that what you think will work will not. Put your generator out, run the house off of it, do a few tests, and make a spreadsheet, laminate it, do whatever of, in the event of a power outage, this is the procedure. Put the generator out, transfer it. These are the loads that we want to be able to run. Can it run the air conditioning? Yes, but only for these times. Can it run the refrigerator? What circuits do we need on? Because then you don't have to stress about it. It becomes second nature. Something happens, your power goes out, you roll the generator out, you connect it. Or even if you've just got a smaller whole home, even a larger whole home generators cannot just run every single thing in your house. Most people's houses now are 200 amp 240 service entrance, and that would be an insane size generator for a whole home backup. You're going to get a lot of people that say, oh, my 22 kW will run everything I'd ever want to. That is true. That is also not true. When you start having multiple air handlers, when you've got a hot tub or a pool pump, or something's got to give somewhere. Know your loads for your size of generator. If you're lucky enough to just have all the fuel in the world and have a huge generator, cool, don't worry about it. Use things as normal. If you have any energy restriction at all, test. Know what you want to run. Know what you need to close off. If you need to relegate to just the downstairs or upstairs or just certain rooms. If you've got just mini splits, anything like that, figure out your stuff beforehand, and then it's a breeze to run in the event of a power outage. You don't think about it. Just have your plan. Also have plans for what happens if your generator doesn't run. What if you run out of gas? What if something messes up and something breaks, or an oil sensor goes out? You know, if you don't know how to fix it and it's a part failure or something, or you don't have the parts in spare, what are you going to do then? That was a big thing for me with the two smaller inverter generators. Even if I get a larger generator, I plan on keeping at least one of these small suitcase generators, because having everything with one generator and it takes that to run it, not a good idea. Same thing if you really want redundancy and you want a battery also, make sure your generator can start your AC unit. Because if it requires the battery to be in combination with it and something happens with the battery system, you can't just bypass it. Whereas if you have a generator that can run it, then you just bypass the whole battery, connect the generator straight into the house, and you're no worse off, maybe just a little more inconvenienced. Overall, the tests went great. I've learned a lot. Hopefully you guys have learned something with it too. If you've got questions of anything, I can try and answer them. I'm sure there will be a lot more videos coming out about all of this, about my solar, some different things. And then I've also got a lot of hurricane prep stuff that I'm going to come up with, wildfire things, just a lot of kind of bug out and emergency prep things and alternative energy stuff and everything. So stay tuned for future videos, and like, subscribe, please. It helps the channel and it lets you know when something's coming up. So I will see you guys in the next one.